All right, on this beautiful day, we're going to be solving quadratic equations using our friend the square root. Square root. And first off, quadratic equation. It's any equation that can be written in this form. ax squared plus bx plus c is equal to 0. Notice that the only restriction on this one is that a cannot be 0. If a is 0, it's no longer a quadratic. It's linear, probably. All right, so what we're going to do is just walk you through. There's not too many complicated things in these problems. Notice our steps that we're going to be doing primarily. Step number 1, we need to get the square, whatever the thing's being squared. In this case, I'm assuming x squared, but it could be any letter or any expression, in fact, can be squared. We're going to get that by itself. Then we're going to take the square root of both sides. And an absolutely key, and you might as well write that here, is when you take the square root of both sides, you have to remember that there's always going to be a positive version and a negative version of that square root. We'll unpack that a little bit further. If need be, you simplify further. And our last thing to do is to check our solutions. You can check using by hand like we're going to do here, or check using your calculator to speed things up. All right, don't panic. This one's not too crazy. Notice that in this case, we already have the x squared is by itself. So that means the isolating part is already done. So the only thing we need to do is take the square root of both sides. Just to fill it in, I'm going to rewrite it down here, although naturally you wouldn't do this. So when we take the square root of the left side, we have to take the square root of the right side. Beep, 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 beep. You have to have the plus or minus there. Let me clean that up. You have to have that plus or minus. So notice our two possible solutions are plus or minus, and the square root of 4 is 2. So we have two answers, or better yet, two solutions. A positive 2 and a negative 2. Why? Because a positive 2, when you square it, you get a 4. So 4 equals 4. Ka-chow. Turns out that when you substitute a negative 2 into the original problem, you also get a positive 4, and that works out as a check as well. Please take a moment now to just attack, kill, destroy, and check. B, go. So when we solve this, we get positive or negative 9. And of course, to do a check, we plug in 9 quantity squared. Does that equal 81? And 81 equals 81. Ciao. And then when we try that with a negative, lo mismo occurs, and we end up with 81 is equal to 81 there. That one's straightforward, and that works out nicely because the numbers that we were dealing with, the 4 and the 81, are perfect squares. That's not always going to be the case. Life doesn't always give you perfection. So step number 1, we need to make sure that my squared component is by itself. It is. Let me just explain to you real quick when it's not isolated. If you scoot over a little bit, you see here, the x squared is not isolated. I have to, at some point and in some manner, get rid of this 3 and get rid of this negative 48. So that's what I mean by isolating the square first. We have to get rid of these guys first before you can take the square root of that. So over here, that's already done for us, so we can skip that. So x squared is equal to the square root of, to 40. Again, you take the square root or the radical of both sides, and you get plus or minus 40. Now we say, wait a tick, that's not a perfect square. So we use our mad skills from yesterday, and I'm going to factor this puppy up. And factor, 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 and pull out my perfect, anything that repeats. I see a 2 that repeats, so I'm going to write the 2 outside. And neither of these two repeat. So that means they stay in as a square root of 10 there. So here are my two solutions. X is equal to plus or minus 2 radical 10. X is equal to plus or minus 2 radical 10. And there's our answer. And you could check with the calculator. That actually speeds it up quite a bit. All right, two unusual things I want to show you for E and F. Notice what happens on this problem here, and I'll just do it up in the box there, just to save some writing. In order to isolate, or excuse me, we've already isolated. In order to isolate the x, get the x by itself, we need to take the square root. And I've so far said put plus or minus. But what is wrong with that statement? Tell your neighbor. So because 0 is neither positive nor negative, the answer is only 0, because positive 0 is the same thing as negative 0. So they're one and the same. So because of that, we just say x is 0. So instead of having two solutions like we've traditionally had in the first 4 problems, if that's tradition, we now have one solution. Now, turns out we could have two solutions like we did down here. We had two solutions. We could have one solution, and we could have no solutions that we are aware of. So I'll just do the work up here. Again, we have to take the square root of los dos lados. Boop, boop, boop. And then we start thinking to ourselves, wait a tick, what's wrong here? We have to ask ourselves what number times itself is a negative. Well, let's see. Negative 1 times negative 1 is positive 1. So that's not it. 1 times 1 is positive. Wait a tick. That's not it. So if it's neither positive nor negative, then what is it? And the answer is no real solution. In fact, don't circle the y equals. Only circle the no real solution part. Because the y equals, there isn't a solution in the system that we've looked at this here in Algebra 1. With that being armed down here, let's do a summary of numbers of solutions, which actually corresponds very well with our graphs that we did a couple days ago. In the condition, we have two solutions when x is equal to a positive number. When x squared is positive, you'll get two solutions. However, we'll get exactly one solution when x squared is 0, because 0 is the only number that's neither positive nor negative. And lastly, we'll have no real solutions whenever x squared is equal to a negative number. Just to show you what this corresponds to is if you were graphing and you had the parabola intersected the x-axis twice. That's what it corresponds to. It's not a perfect correlation, but we're saying it's similar to it. This one here corresponds where we have the parabola is just touching the x-axis in one place, just like that. It's just touching the x-axis in just one place. And lastly, this one here is when the parabola never touches the x-axis, as in this case here. There's no x-intercept. All right. So G. G is going to do all the steps that we have that we need to do. So number 1, we need to get rid of the two. I have a negative 48 and I have a positive 3 that's multiplying, and I need to get rid of those. So we're going to start with this one to add 48 to both sides. Now, if any of you had said divide both sides by 3, technically you're right. You just have to pay attention to what you're dividing. Everything needs to get divided. So now I'm going to bring the 3x squared equals positive 48 down. And now the only thing left to do for isolating there is I need to divide both sides by 3. So now I bring down the x squared equals a positive 16. And our last step is just like we did before. We are going to take the square root of both sides. Don't forget when you take the square root, beep, 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 plus or minus there. And our final result is x is equal to plus or minus 4. I'm going to double check that by plugging the positive and the negative 4 into the original equation. So that's already set up for us down here, so let's do that. Let's start with the positive 4, see what we get. Notice, do not multiply 3 times 4 here. The first step is to square it. First step is to square it. So 3 times 16 minus 48 equals 0. Then 3 times 16 is positive 48. We bring down the minus 48, 0 equals 0, and it's a check. Notice that when I do the same with negative 4, I plug things in, I get the exact same situation as I do right here, and so there's no sense in repeating it because it's the same idea. Because negative 4 squared is the same as positive 4 squared because the square kills the negative. There we go. Let's add 1 to both sides. Bring down the 4x squared is equal to positive 1. There we go. All right, now we're going to divide by 4 on both sides. And bring down the x squared is equal to 1/4. So we're going to take the square root of both sides here. Square root here, square root there. Don't forget the plus or the minus. So here, without a calculator, you can just square root 1 and square root 4 to get 1/2. If you plug it into your calculator, you'll get the same result. So the answer here is x is equal to plus or minus 1/2. If you used your calculator, that would have been fine as well. Now, of course, you can check your answers with the calculator. The next thing that we're going to cover is all about something called the falling objects model. So this is a very common model in algebra and physics, in fact, and it looks like this. The height of an object when it falls, so it's not being thrown in the air, it's not being tossed down, it's just dropped, is negative 16 t squared plus s. And let me explain what each one of these things mean in context. H means the height of the object at t seconds. So after 1 second, you put a 1 into there. After 2 seconds, put a 2 into there. T, of course, is time, and in general, it's in seconds. And S means the starting height. Starting height. So if you're up 6 floors, then you're at 60 or 50 feet, depending on what part of the floor you're on. All right, so let's walk through this. Mr. Swanson is cliff jumping from a height of 32 feet. How many seconds will he be in the air? How many seconds will he be in the air? So 32 feet, that's the top floor, pretty much, of a third-story building. So jumping down and landing safely in water, how long will it take? So maybe my estimate is, wow, 3 stories, that's quite high. Maybe 2 to 3 seconds, I might estimate. What we're going to find out is that our estimates are going to be probably off kilter. So the height is, we actually know the height because hits the water. The height is going to be 0. And the time is unknown, but the starting height is 32 feet. So let's have our equation. T squared plus s, and we're going to substitute things in. 0 represents the ground. Negative 16 represents how fast gravity pulls things down. And we don't know what t is yet. And we add that to 32 being the starting height. Now we're going to do what we had just done a few moments ago, where we're going to isolate the t and then take the square root. So subtract 32 from both sides. Then we need to divide both sides by negative 16, like so. And we end up getting a 2 here and a t squared there. Now we take the square root of both sides. Don't forget that there is mathematically a plus or minus. And now let's finish it up over there. And we get t is equal to plus or minus the square root of 2. Now the question, of course, is asking us how long, how many seconds will he be in the air? But the square root of 2 doesn't really make sense to me. So you're going to pull out a handy-dandy calculator. And when you do that, you get approximately 1.414 seconds. Now, let's see practically about what happens here. Positive means the future, and negative means the past. And since we can't time travel, we're going to ignore that entirely and only consider the positive. So there we go. In less than 1.5 seconds, the Swenson will hit the water. All right, now your turn here. with 64. Go. Pause this video and then come back to see solution. All right, notice that it only took about 1.5 seconds here, so we say, oh, double that, right? Should take maybe 3 seconds here. But again, the height is 0, we don't know this, and 64. So let's plug it in, and we're going to put 0 when we hit the water, negative 16 t squared at a height of 64. Subtract from both sides, and then divide, and that'll give me a 4 t squared. And when you take the square root, you get plus or minus 2 seconds. 2 seconds. 7 floors up. 2 seconds. And that's what we end up getting. All right, your assignment is to finish up down here. Be well. Fare thee well.